I would suspect, though, most of you have questions regarding the handout that I gave you yesterday. But if you don't, then go ahead and ask whatever questions you have. So the floor is open. Go ahead, James.
Did you use 16 in that handout?
1, 6?
Yeah.
Yep. So a group of people exchange handshakes, and there are 171 handshakes, and then a second group has 4 more people. So there's 2 aspects to this question. One of them is you are expected to know how to find out how many handshakes there are in a group if you know the number of people. The other aspect is you should be able to find out how many people are in a group if you know the number of handshakes. And the basic idea is the total number of people in a group, choose 2, will always give you the number of handshakes. Well, I want to be careful here with always. I mean, I can come up with a different scenario, and I'll describe it in a minute, where this doesn't apply. But if you have a group of people, and you're told that everybody in that group shakes hands with everybody else in that group, this is how you find the number of handshakes. So we have 2 groups. I'm just going to call this group 1 and group 2. Group 1 has 171 handshakes, and that means that some unknown number, choose 2, has to give you 171. Now, you were expected to know, everybody, how to solve this little equation algebraically. And I'll maybe get to that in a bit, but this is not a written response question, so if I were trying to get an answer here to this question, I would simply go to my calculator. I mean, we could start guessing. You know, you could say, well, maybe it's 30 people, maybe it's 15 people. But the most efficient use of your time, I think, is to go into Y and put X choose 2, and then just check to see that your table is set up so that you can navigate easily. And when I go to my table, I'm looking for 171 handshakes. So when X is 19, 19 choose 2 is 171. That means there are 19 people in the first group. Okay. Now we know that in group 1, there are 19 people. That means we can move on to group 2. We don't know how many handshakes there are this time, but we do know in group 2 there are 23 people, because we're told that there are 4 more people in group 2 than in group 1. And I can see already you know what to do, right? What we're going to do then is take that 23, choose 2, and see what we get for the handshake. So we took the information from group 1, found the number of people, used information in the question to determine the number of people in group 2, and then we found the number of handshakes. And you get the right answer, right? Okay. Can you tell me what it is?
It should be
252? 3. Thank you. Is that good, James? Hey, other questions? Go ahead.
Can you do 18, please?
18, absolutely. So again, this is just my way of telling you there's lots of things you need to be able to do, and I'm just packing 2 things into one question. What you have is 2 situations. You have 4 motorbikes and 4 cars that are going to be parked in a line, and you have to alternate positions. It has to be motorbike, car, etc. This is no different than questions we've done in class where I said we have 4 boys and 4 girls, and they're going to alternate. The idea is that you certainly don't need to draw the 8 positions, but I want to put them up here so we can talk about them. If I want to alternate the motorbikes and the cars, then this is a possibility, isn't it? But what you want to do then is just not worry about the motorbikes. Just say, how would I arrange the cars in that position? And the answer is, it would be 4 factorial ways to put the cars in those alternate positions. So we have to arrange the cars, and we can use the same logic for the motorbikes. We have to arrange the motorbikes. But that is not going to be the number of ways that they can alternate. Because there is an even number, not an even number, that came out wrong. Because there is the same number of motorbikes and cars, I can start with motorbikes or I can start with cars. So I also have to decide, I mean, if you want everybody, you can simply say it can be this one or this one, right? So there's two possibilities. But if you want a more mathematical, sophisticated approach, you multiply by 2 factorial because you have to decide what vehicle goes first. And there are two options, motorbike or car. So that's the first part of the question. Now the second part of the question, I'm going to erase what I just copied down here. Okay, I'm not going to refer to this in the first part of the question. What do we have? In the second one, we have 4 motorbikes and we have 5 cars. Well, the simple fact of the matter is then that since you have 5 cars, you have one more car than motorbike. In order for them to alternate, you have to start with a car, right? So forgetting about these codes and colors, it has to be car, 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 motorbike, 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 motorbike. You cannot start with a motorbike because then what's going to happen is you're going to have 2 cars left at the end and you can't alternate. And so what happens here now for the second one, and there's a typing mistake here. This should be a B. Is it a B on yours? No, it should be a B. Yeah. This will be equal to 4 factorial times 5 factorial because you have to arrange those 4 motorbikes and you have to arrange those 5 cars. The difference is that's it. You're done. You can't multiply by the number of different vehicles you can start with because you have to start with a car. So we can go through the calculations here. The number of ways to do it in the first one is 1152, and in the second one is 2880, is what I get. So 2880 is bigger, which means 2880 B minus A, which is 1152, gives you 1728. So the correct answer is C. Is that okay? All right. You're welcome. Other questions? Go ahead.
20.
20? I've seen this question asked before where they don't say it's n tiles, they say it's, say, well, let's try it with a number of tiles. Let's just say we have a game and there are 10 different tiles. So, you know, A, B, C, D, E, F, G, H, I, J. And you have those 10 tiles and they're all different, but you're going to take 2 sets of them. And what that would mean, so this is just a hypothetical, this is not the question yet. 10 different tiles, and we're going to double that. So what that means is you have this. You have those 20 tiles, right? So how would you determine the number of ways to arrange these? Well, you would say there's 20 objects, and I need to do a factorial of that. But then you would say I have identical items or repeated items. I have 2 A's, and that would mean I would have to divide by 2 factorial. But I would need to divide everybody by 2 factorial a total of 10 times, wouldn't I? So I don't feel too happy about having to write 2 factorial 10 times. I can write 2 factorial to the 10. And I suspect you see what the answer is immediately. What we're doing is we're taking the number of tiles n and we're doubling it to get however many tiles there are in total. And we have to go that number factorial. And then we have to divide by 2 factorial for each of the type of tile. So if there were 10 tiles, we would raise that to the 10. If there are n tiles, we're going to raise this to the n. And it's a question, I think, that is best by simplifying it into something easier with numbers and then seeing if you can recognize what we would do if we don't know the number. So the correct answer is D. Other questions? Louise? 32? So a security code, it's just a code. It could be a code to enter a room in a building. It could be a code for a photocopier. It could be anything. But it happens to be a security code. Consists of 2 odd digits. So let's just, right out of the gate, let's make sure we understand that these are odd digits and these are even digits. So in our number system, everything we do with numbers in math, we have 5 odd and 5 even. So basically this question is saying we have an old security code that consisted of 4 where this was odd. I'm just going to put O for odd. This was odd. And this was even, oh, 4 even. So that's the old system. The new system uses 2 even followed by any 3. So it actually has fewer digits. But they're doing this because you're going to increase the number of codes, even though we have fewer digits. It says repeated digits are allowed. What's the increase in the codes? Well, let's figure out how many old codes there were. There are 5 even, 5 odd, so all of these numbers are all 5s. In other words, this is 5 raised to the 6. On the other hand, the new code says this must be even. And by the way, these don't go 5, 4, 5, 4, 3, 2, etc., because we can repeat. Right? The new code would be 5, 5. And I didn't write up here, but we know the fundamental counting principle says that we multiply these things together, right? But then since these can be any, it's 10, 10, 10. And when we multiply those together, we get 25,000. Now I have no idea what 5 raised to the 6 is. But I'm about to find out. It's 15,625. So if I want to find out how many additional codes we generate, 25,000 minus the 1728. No. Where did I get 1728 from? Wow. Minus the, oh, I'm looking at it right there, 15625. So I'm getting 9,375 additional codes. Is that good? Okay. Other questions? Yeah.
33.
33? It's a greasy kind of question. There's not much to it when you see it. You might get lost in this. Like, what's the deal with that? Well, what I could say is if choosing 3 tiles out of a bag of 20 is the same as pulling this many out, what's the value of k? I could say, well, k is -2. Because -2 plus 5 is 3. That's not what we're getting at. We are getting at the idea that 20 choose 3 is the same as 20, choose 17. And you can see where we're going with this. Because if I have a group of, let's just say there are 20 people in the class right now, 20 students. And again, I'm going to take 3 of you out for ice cream. For each group of 3 I take, there is a group of 17 that don't get to go. So however many groups of 3 there have to be the same number of groups of 17, because 3 plus 17 add to give 20. That's the deal here. And what that means is that this has to be equal to 17, which means k has to be 12. There's not really a big algebraic or formulaic way to do this. It's just reasoning out that that's the case. $17? I remember seeing, I don't know when it was, sometime in the past 5 years or so, there was a question that talked about different colors of paint, and you had all these rooms in the house. I have no idea the specifics of it, but it was something like, if the living room and the kitchen have to be different colors, but the 2 bathrooms have to be the same, and all this stuff. And I thought, well, that's a pretty good question. So I designed something that is kind of along the same lines. Again, I don't quite remember the exact details of that question, but we have a wooden board with 7 hooks. And we have unlimited rings. And what this means is if you wanted to, and there are 12 different colors, whatever one of the colors is blue, you have enough rings that you could put blue on everything if you wanted to. Okay? And what you're going to do is you're going to hang 1 ring on each hook. And here are the conditions. The first 3 hooks have to be the same colored ring. So let's say one of the colors is blue. Blue, blue, blue on the first 3 hooks is allowed. So is green, 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 etc. So that's one of the things that has to be followed. The next 3 hooks have to all have different colors from each other and from whatever color you used in the first 3. So if you had blue, blue, blue on the first 3, then the next 3 could be green, red, purple. But it couldn't be green, red, blue because you've already used blue. That's the condition. The final hook needs to be one of the colors already chosen. So it has to match one of the previous hooks. How many different ways are there to place the rings? Well, here, the way I look at this, you need to do the following. You need to choose the color for hooks 1, 2, and 3. You need to do that, right? You need to choose, well, yeah, I'm going to say choose the colors for hooks 4, hook 4, 5, and 6. And what I'm writing here is really obvious. You need to choose colors for all of them, but I want to break this down bit by bit. And you need to choose the color for hook 7. Okay, those are the things you need to do. There's something else you need to do as well that I will get to in a second. So, how many ways can you choose the color to use for hooks 1, 2, and 3? 12. There's 12 colors, period. Now, how many ways, this is tricky and it depends on how we're going to look at it. How many ways can we choose the colors for the next 3? Well, if I think of combinations, then it's going to be 11 choose 3. Okay? But because the hooks are in different locations, we have to arrange those 3 colors on the hooks. So I also need to multiply by 3 factorial. Because if I choose blue, green, and red, because yellow's been already used in the first three hooks, if I choose blue, green, and red for the next three, blue, green, red, and blue, red, green, and those are all different. And I need to choose a color that's not already been chosen. And at this point, I've used up 4 colors. So there are 8 left. And that will give you the answer. There's another way to look at it, though, and the reason I did it this way is this makes more sense to me. Yep. Oh, it's the same color. My mistake. I thought it said it's a different color. If it's a different color, it's 8. If it's the same color as one of them, it has to be 4. Okay? Now, the reason I did it this way, we can get an answer, but it will be the right answer. The reason why I like doing that is that makes more sense to me. You could have said, well, not choose here, but how many ways to choose 12, the color for the first, this? For the second, you could have said, how many ways can I hang the hooks? In which case you could say 11p3, because it's ordering. But that's that thing that I talked about where I say, let's say there are 11 empty seats on a bus. How many ways can 3 be seated? I don't like 11p3. In my mind, you're saying you're arranging 3 seats out of 11. You're not. You're arranging people in 3 seats. So I prefer to choose the seats and then arrange the people. But in either case, this will give you the answer. Okay. So we're expanding, and very often on my exam and on diploma exams, the binomial theorem problems are not really complicated ones. Here's an example of x plus y to the n, testing the basics of the binomial theorem. It says one of the terms is ax cubed y to the 5. So right away we can see that n is 8. Because the two exponents are 3 and 5, the sum of them gives you the exponent on the binomial power. So what we're talking about here then is x plus y raised to the 8. Now, just a second here. How many terms are there? There's always one more term than n. So we're dealing here with 9 terms. What is the value of a? Okay, so this is how I approach it. Okay, I'm not a formula guy when it comes to the binomial theorem. I just know that a term has n choose the key number. And I know that the key number is always the number that y is raised to. Right? In other words, we're talking about the 6th term here. Because the key number is always 1 less than the term number, and because I can see that this is the key number, because it's always the exponent on y, in a case of x plus y. And that means I have 8 choose 5, and then I'm going to have x to the 8 minus 5, which is 3, and y to the 5. So whatever 8 choose 5 is, and I have to believe it's probably going to be 56. I don't know what the answer is, but it seems reasonable. That means now we've paired off these two, so the answer is C. Are you okay with that? Yeah. Okay. Other questions? Go ahead.
22, please.
22? So we have a multiple choice quiz. There are 6 questions. You're told that each of the questions has A, B, C, D. It's a standard multiple choice. How many different answer keys are there? And this is going to be A. So the idea is, with the fundamental counting principle, there are 4 possible answers for question 1. There are 4 possible answers for question 2, for question 3, for question 4, for question 5, and for question 6. And of course, you have to, if you want to generate a full key, you know, A, B, B, A, D, C, whatever, you have to do all of them. You have to do question 1 and 2. I'm not going to design a multiple choice quiz with 6 questions and not have an answer to one of the 6. So this value of A is 4 raised to the 6, whatever number that is, and we'll calculate it in a second. Now, the second multiple choice quiz has more questions, but the teacher is designing it so he or she wants 2 A's, 2 B's, 2 C's, and 2 D's. And I think the only way to wrap your head around this one, and it's a totally different solution than the previous one, is to say that you need to arrange these 8 letters. Each arrangement of those 8 letters will be one of the possible keys that I could make. So we're talking here about arranging items where items are identical. You're simply going to say that this will be 8 factorial, but I need to divide by 2 factorial because there are 2 A's that are identical. So if I generate a key and A is the answer to 1 and A is the answer to 7, and I switch those 2 answers, A is still the answer to 1 and 7. You with me on that? Okay. But we have to divide by 2 factorial 4 times. What I mean by 4 times is not times 4, but raised to the 4. I need to divide by 2 factorial for the A's, 2 factorial for the B's, 2 factorial for the C's, and 2 factorial for the D's. Can you calculate that for me and let me know if you get 360? No? Oh, my mistake. I'll say 2520. Okay. How embarrassing. I thought 7 factorial was 720. When we go 4 to the 6, I couldn't even begin to. That's just not in my brain. I could maybe work it out, but 4096. By the way, when you see this A minus B, B minus A, this isn't because you see this on diploma exams or even my exams. It's just my way of asking a couple of different questions. You know, I think it's a good way to ask a question, but I rarely see it. So A is larger than B, so it's going to be one of these 2. And then I need to take 4096 minus 2520, which can't be 840. It's got to be 1576. So the correct answer is B. Other questions? You know, we're getting to a stage as we're going through all of these where I can say to you something I think I've alluded to before. There's so many types of questions here. There really are. I've told you before that, you know, we learn this much material in each unit and I only get a chance to ask you this much on an exam. Here it's even smaller proportion of what we learn. There's hundreds and hundreds of different types of questions. You don't know which 15 or 20 I'm going to ask you about, so you have to know how to do them all. We have 6 men and 8 women. We're going to choose a 5-person committee, but there's a condition. You need representation from the men and the women. You need at least 1 man and at least 1 woman on the committee. In other words, you cannot have an all-man committee and you cannot have an all-woman committee. And that leads us to the solution to this problem. If we take 14, choose 5, we will be finding how many committees are possible without any restrictions. But if I take off the all men and the committees, and I subtract the all women committees, then I will be left with the committees that have at least 1 man and at least 1 woman. So what we can do is easily overthink this for this next part. The bottom line is how many of the committees would be all men? Well, it would be 6 choose 5. If you want, you could say and 8 choose nothing. I mean, you could do that, right? We also need to subtract the all women committees. How many ways are there to select 5 member committees out of a group of 8 women? 8 choose 5. And again, if you wanted to be clinical about it, or technical, whatever the word is you want to use, you could put times 6 choose 0 because of the 6 men, you're not choosing any. But n choose 0 is 1, so you don't need to write that green stuff. And that's going to give you the answer. That looks like a 19, but it's a 14. Let's see what we get here. 14 choose 5 minus 6 choose 5 minus 8 choose 5. 14 choose 5 minus 6 choose 5 minus 8 choose 5 gives us 1940. Is that okay, Markman? Other questions? Yeah. 36. So we have a bag of marbles. There are 4 marbles in this bag, and we have 4 marbles in a second bag, and all 8 marbles are different colors. Okay, they're all different. Person reaches into the first bag and pulls out 2 marbles, and reaches into the second bag and pulls out 2 marbles. How many possible sets of marbles are there? You know, this is the same as saying we have 4 men and 4 women, and I want to make a committee of 4 that has 2 men and 2 women. It's the same thing. If I said, how many ways are there to select a 4-member committee out of this group of 8 people? So we have the same number of men and women. You would say, well, I have to choose of 4 men 2 and of 4 women 2. And that's all that's happening here. In the first bag of the 4 marbles, you need to choose 2 of them, and of the 4 marbles in the second bag, you need to choose 2 of them. And that's it. And 4 choose 2, I'm pretty sure is 6. 6 times 6 is 36. Now, had I gone a step further, I can ask a different question. A person reaches into bag 1 and grabs 2 marbles, and reaches into bag 2 and grabs 2 marbles. How many ways can they arrange those marbles on a table? In which case, you would say 4 choose 2 times 4 choose 2 times 4 factorial, because you're arranging them. Okay? And this is very similar. There's as many different questions as there are, so many of them are similar. This is similar to, didn't we have an example assigned problem where you had to choose 2 letters from the word slimy and 2 letters from the word frog and arrange them? It was how many different 4-letter arrangements can be formed using 2 letters from each word? And the answer was 5 choose 2 times 4 choose 2 times 4 factorial, because this plus this is 4. Which is no different than saying, what's a word I can use here? Integral. No different than saying how many 4-letter arrangements using 2 vowels and 2 consonants from the word integral. Right? It's the same thing. It's not slimy and frog. It's not bag 1 and bag 2 that you're arranging. It's, what do we have? Vowel vowel, vowel. We need to choose of 3 vowels 2, and of consonant, 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 consonant. 5 consonants, we need to choose 2, and we need to arrange them 4 factorial ways. Again, though, I want to make sure you understand, everybody, the question that was just asked, number 36, does not ask us to arrange them. So we stop here, right? We don't do this in this question. But if it did say, oh, and by the way, you got 4 holes drilled into a table, how many ways can you put the marbles in the holes? Then you would do that. Is that okay, though, Miss? Other questions? While we are kind of in a lull here, just a brief discussion of your exam, 15 multiple choice numerical response, same as always. 1 written response with a part A and part B. What I would tell you about the written response is it's going to be algebraic. So whether it's solving an equation, I give you an equation that has factorials in it, go ahead and solve it. Or, you know, let's talk just for a second here about a question that James had asked about, and I can't remember where it is. It was the handshake thing. I'll find it. It was this question. And that discussion of the written response just triggered my memory that I had said when I wrote n choose 2 equals 171, I said, and you are expected to know how to solve that algebraically. Well, let's talk about that. There's no way I'm going to do this question for you right now if I'm going to ask this kind of question precisely on a written response, okay? So don't get your hopes up. But if I told you this would be, I would think, a 2-mark written response question. There are, 171 handshakes. Algebraically determine the number of people. You get the gist, right? I just don't want to waste time writing it down. So what you would do is you would reason out that it must be n choose 2 equals 171. This is a really easy one to solve because it's choose 2. If it's choose 3, it becomes a little bit more involved. According to your n choose r formula, n choose 2 will be n factorial over n minus 2 factorial, and this is equal to 171. I really think this is an easy 2-mark written response question. We can go ahead and multiply both sides by 2. How is my multiplication? 2 times 171 is 342. Okay. And, 2 factorial is 2. But you need to write the factorial where I did. And then you would say, oh, right, I've got 2 factorials that are close together. I'm going to expand the bigger factorial. And then I'm going to indicate on the written response that this is n minus 2 factorial. So they cancel, and I'm left with n times n minus 1. And that's a grade 11 question now at that point. You're left with n times n minus 1 equals 342. As much as it's a grade 11 question, I want to finish it to talk about a strategy here. It's a cheaty kind of strategy. This factor or multiplies into n squared minus n and then minus 342. And now you have to factor this. And as much as your grade 10 teacher would tell you, oh, this is easy because the coefficient of the quadratic term is 1, it's not easy. Not for me. I cannot even begin to fathom what 2 numbers multiply to give negative 342. But there's a couple of ways that I can cheat the system. One is to find out what the answer is on my calculator first, right? What was it, 19, by the way? I mean, I think we've already done this. It's probably still in there. It is. Right? Oh, it's 19. So behind the scenes, I don't write down on my exam, oh, I went to my calculator and figured out that it's 19. I keep that to myself. But if I know it's 19, then I know one of the factors is n minus 19. The other one must be n plus something because they multiply to give a negative. So then I go 342 divided by 19, 18. Lo and behold, these two numbers add to give negative 1, which they should. And that means that n equals 19 or n equals negative 18. I'm not going to write this, but you need to have a discussion on paper with your marker about why you're going to take the negative 18 and not consider it as a solution. Whether it's you cannot have a negative number of people, or n choose 2, just in a most general algebraic sense, is not defined unless n is bigger than or equal to 2. We can't have an n smaller than 2. You know, I've seen this question in a number of different sources over the years, and every time I do it, I think there's got to be a simpler way, and there just isn't. Okay. It's a brain buster. You have 5 different types of fruit and 6 different types of vegetables. We want to make a snack tray by choosing 2 fruits and 3 vegetables. So this is all about combinations. This is not ordering things. How many different snack trays can be made if these are the conditions? Your snack tray has to have blueberries, or it has to have carrots, but it cannot have both. Okay. So what that means is your snack tray can have blueberries and not carrots, or it can have carrots and not blueberries. And again, I've spent a lot of time on this question, or questions similar to it, trying to find out if there's a way that we can weasel our way around all of this work, and I don't think there is. It's not a simple approach, if there is one. So what I'm going to do here is when I say I have 5 different types of fruit, up here I'm going to put 1 blueberry and 4 other fruit. And when it says 6 different types of vegetables, I'm going to put 1 carrot. It's not a single carrot, but you know what I mean. And we have 5 other veggies. Just want to make sure that adds up to 5 fruits, that adds up to 6 veggies. So now let's figure out how many trays would have a blueberry but not carrots. So we need to choose the blueberry, that's 1. And, so this is the blueberry, and we need to choose 1 more fruit. I mean, I'm going on the assumption here that you understand a blueberry is a fruit. Okay. And we have 4 other fruits to choose. Okay. And we need to choose 3 veggies, but it cannot include a carrot, right? Because we've got blueberries. So not a carrot. So how many veggies do we have to select from? 5. 5 choose 3. That's what we would put here. So let's just run through this again, mainly as well, for not just for your benefit, but so that I can reason it out so that my thinking was valid. I'm talking about blueberry and not carrots, but we still need 2 fruits and 3 veggies. So I have my blueberry, that's 1 fruit. I need 1 more fruit, and I have 4 to choose from. And I need 3 vegetables, but since I have blueberries, I can't have carrots, so I need to choose of the 5 other veggies, 3 of them. Okay. Or, well, let's do the carrot. There's 1 carrot, and, well, I want 3 veggies. I need 3 veggies, so that means I need 2 more veggies, which means this will be 5 choose 2. I need 2 more out of the 5. And, so these are the other veggies to complete the 3 veggies, and I need 2 fruits, but I cannot choose a blueberry. So your math teacher poking you with a sharp stick trying to get to the answer here. That's what this kind of question is like. So how many fruits can I have to choose from? 4. I cannot choose the blueberry. So this is 4, choose 2. So by my count, 5 choose 3 I think is 10. 10 times 4 is 40. 5 choose 2 is 10. 4 choose 2 is 6. So this gives us 60. The correct answer is 100. That's just an exercise on your brain. There's almost always on the diploma exam a real tough one, but this is maybe going too far. Real tough one like the rings on the hooks, or I've seen a question where you have a van with 2 front seats and 6 passenger seats in the back, and an adult has to drive, except one of the adults doesn't have their license, and children are not allowed to sit in the front, but you need one adult in the back, and all these weird things. But this takes it to the next level. I don't know. To me, in my mind, if you find the total number of of trays and you take away the ones that have carrots and blueberries, that should give you the answer, and it doesn't. Because what you also have to take away is the number that don't have carrots or blueberries, because we want one or the other. So you could do it that way, but it's more work. Other questions? James? 37? Let's summarize this information. We need 6 people. Right, we need 6 people. And this is the pool of people we have to choose from. We have 10 chemists, 15 politicos, politicians, 8 economists, and 15 biologists. We want at least 5 chemists on this committee of 6. And what that means is 5 or more. Now, what does more mean in this context? It doesn't mean you can have 100 chemists. Number 1, you don't have that many chemists. Number 2, you can only have 6 people in total. So what this boils down to is you need committees with 5 chemists or with 6 chemists. And as soon as I get to this point, James, where I say that's what I'm after, all I really care about then is that there are 10 chemists and there are, if my arithmetic is right, 28 other people. I don't care what those positions are. So how many ways can I get a committee of 6 people with 5 chemists? Well, that would be 6 choose 5 times 28 choose 1. Why? Well, because I'm choosing 5 chemists of the 6, and I need 1 more person to complete the committee, because I only have 5, so I want to get up to 6. And that 6th person is going to be a non-chemist, so that's why I use 28 choose 1. Or, which means add, 6 choose 6. Now, we're lucky here because we actually have 6 chemists, or we have 10 chemists, so we have more than enough chemists. But maybe if there was only 5 chemists, you'd have to end it there because you can't have 6. Anyway, so I've made a mistake here. This is not 6 choose 5, this is 10 choose 5. I was thinking of a different question where you had 6, you had the same number as the number on the committee. So 10 choose 5 times 28, and then 10 choose 6 times, if you want, you can put 28 choose 0. Is that okay? Okay. Other questions? Go ahead. 24? So, we're going to expand this, and one of the terms is going to contain an x squared. If you want to find out what that missing parameter or letter a is, then you need to figure out what that term actually is equal to, which means you need to know x, y, n, and k for this term, right? Well, for all of the terms, n will be 6, always, in this example, because it's a binomial raised to an exponent of 6. For all of the terms, x will actually be 3x squared, and y will actually be negative 1/2. Okay? But the k value will only be a k value for this term. So this is the part that you have to get past. We have to find out what value of k we use. In other words, we have to find out what term it is, because if we know, for example, it's the 4th term, then k will be 3. And how we can do it, there's one of two ways. This would be a good kind of way to end the day, to go over this again. There's one of two ways, and it's to say, I'm going to make a table, first term, second term, etc. And I'm going to figure out what the variable component of each term is. So I know that the first term is going to contain an x squared to the 6. It's also going to contain a 3 to the 6. It's also going to contain a 6 choose 0, which is just 1. It's also going to contain a negative 1/2 to the 0, which is just 1. But the variable part will be x to the 12, which does not match the term we're after. So, what about the second term? Well, the second term would also contain x squared, but it would be raised to the 5. And I think it's more obvious in this example than maybe some of the other ones. What's happening to x is we're losing 2 each time because you're losing an x squared each time. Some of the other ones you're also losing x's because there's over x in the y. But what this means is we can continue this pattern until we get to x squared, because we want, I'm going to make it fit just barely, because the term we are after has an x squared. So now what we can add to our list of knowns is that since that's the 6th term, k is equal to 5. And now we can go ahead and use, remind me here, Armand, are you the kind of guy that likes to look at that formula when you do this? Okay, so it's going to be n choose k, the 6th term, which is 5 plus 1, will be n, which is 6, choose k, which is 5, times x, which is 3x squared, raised to the 6 minus 5, multiplied by 1/2, raised to the 5. I think it's pretty obvious you're going to get an x squared out of that. The coefficient will be the product of 6 choose 5, which is 6, and 3 over 2 to the 5, which is 32. And this gives me 18 over 32, which reduces to 9 over 16. I hope it said a over 16 up here. So A is 9.
Is it also possible to find K algebraically?
Absolutely, and that's what I want to finish with.
Okay.
The question being here, can we find K algebraically? So we know that this term is A over 16 times x squared, and we know that every term will be 6 choose K, x, which is 3x squared to the 6 minus K, y, which is 1/2 raised to the K. Now, because we don't know the coefficient here on the left of this equation, but we know x squared, we're going to focus our attention on this. Everything else is a coefficient, or is part of the coefficient. I'll just be even more obvious here. Whoops. That this is our x squared, and this is our coefficient, right? So it's a comparison thing. We're saying x squared has to equal x squared to the 6 minus x, which seems weird. We're going x squared equals x squared, okay? Let's just go with it. So we multiply the exponents. A power of a power says you multiply the exponents. Now I can say 2 equals 12 minus 2x. And I had mentioned the other day, as an apology, boy, my k's look like x's sometimes. And somewhere along the way, I started writing x instead of k. So 2k equals 10. K equals 5. Absolutely. And I think that's the cleaner approach. You know, I'm always hesitant in having somebody write out tables on a written response. I'm fine with it. I'm not going to say, oh, that student doesn't know how to do it algebraically. I'll give you the marks. But on a diploma exam, they might be looking for an algebraic approach. It's hard to say. So same thing as always for your exam. You get the full class plus 15 minutes past the bell. Just because we're done working on this together doesn't mean you're done. You should be doing some more work between now and tomorrow, I think, getting some more practice. And when the bell rings, have a great day, and we'll see you all later.